Good morning, dear student. Today we will discuss inbreeding. So, first of all, what is inbreeding? Inbreeding happens when individuals that are related to each other by ancestry and they mate together. In a smaller population, the degree of relationship between individual increases because with fewer ancestors, everyone become more closely related. That's why in smaller population, inbreeding occurs more often. In a population of any bisexual organisms, every individual has two parents, four grandparents, eight great grandparents, and so on and so forth. And after t generations back, it has 2 raised to power t ancestor. So we define inbreeding. Inbreeding is mating of individual which are related by ancestry. So we are talking about, if we talk about t generation back, it has 2 raised to power t ancestors. So any pair of individuals must therefore be related to each other through one or more common ancestor. Thus, pairs mating at random are more closely related to each other in smaller population than in a larger one. This is why the properties of small population can be treated as the consequences of inbreeding. So we can say inbreed individuals, that is to say offspring produced by inbreeding, may carry two genes at a locus that are replicates of one and the same gene in previous generation. So smaller population have higher chances of inbreeding. Now, what are the effects of small populations? I have already told that individuals in small population are more closely related. Inbreeding results in offspring with two genes at a locus from the same ancestor. So now we will define what is inbreeding. So definition of inbreeding is nothing but it is the mating of related individuals, and coefficient of inbreeding, which is represented by capital F, is the probability that two genes at a locus are identical by descent. So it is probability that two genes at a locus are identical by descent. And here F represents the correlation between the two uniting gametes. So if we talk about the idealized population, so a base population with an individual, I have already told in previous lecture, shedding equal number of gametes and all genes at one locus are non-identical, means A1, A2, A3, etc., etc. So in the first generation, the probability that a pair of gametes will carry the same gene. So if we talk about the generation 1, then the probability that a pair of gametes will carry the same gene is 1 by 2n. So Now, this gives us the coefficient of inbreeding for generation 1, that is F1, which is given by 1 by 2n, means the probability that pair of gametes carry identical genes. Now, in second generation, identical homozygotes can occur in two ways. Either from the newly replicated genes or from the replication that occur in the previous generations. So the total probability of identical homozygotes in generation 2 is given by say F2, which is equal to 1 by 2n. This is 1 by 2n. Uh, this is given by 1 by 2n 1 by 2n plus 1 minus 1 by 2n into f1. This f1 is the coefficient of inbreeding in generation 1. So if we talk about in tth generation, the ft is represented by 1 by 2n plus 1 minus 1 by 2n into ft minus 1. So if we denote say delta f, the increment, then we may define delta f as 1 by 2n, and all these relations can be written in terms of these. How? So for example, if we talk about f of t, it is equal to 1 by 2n can be replaced by delta f. So it is delta f plus 1 minus 1 by 2n, again it is delta f into f of t minus 1. So in this way you can find out the coefficient of inbreeding in tth generation. So this delta f is generally defined as increment or rate of inbreeding. So the rate of inbreeding I have already said it is delta f 1 by 2n. So this journal formula can be obtained as ft is equal to delta f plus 1 minus delta f into ft minus 1. So now if we talk about the idealized population, so we may define one more term which is known as panmictic index. So panmictic index is generally represented by capital P. It is the complement of inbreeding coefficient. Means if f is my inbreeding coefficient, so 1 minus p, or it is p can be written as 1 minus f. So it is the complement of inbreeding coefficient, and its formula I have already told you that p can be written as 1 minus f. So we can generate the modified equation using this p and 1 minus f. So the panmictic index, that is in generation t, can be written as 1 minus delta f, which I have already told you it is p t minus 1. So how this formula created? I just explain it. So first of all, we will write out the journal formula. Pt is equal to 1 minus delta f pt minus 1. How this formula derived? So we know that ft, which we have developed as delta f plus 1 minus delta f into f of t minus 1. If we replace ft as 1 minus say pt. So just substitute this. I will get 1 minus p of t will be equal to delta f plus 1 minus delta f, and this can be written as 1 minus p t minus 1. So it is 1 minus pt is equal to delta f plus, if I open multiply these two terms, I will get 1 multiplied with 1, it is 1, and 1 multiplied with minus delta f, so it is minus delta f, minus pt is multiplied with 1, so it is minus pt minus 1, and it is delta f pt minus 1. So if we simplify it, this one cancelled with this one, sorry, this one is cancelled with this, and minus pt will be equal to this delta f cancel with this delta f. So what we have remained? We have remained these two terms. So if I take pt minus 1 common from these, so I will get, minus, you can say pt minus 1 can be taken common. So 1 minus delta f. This minus cancelled with, so I will get this expression. So right, this shows that the panmictic index reduces by a constant proportion in each generation by this term. So if we talk about successive generations, what will be the panmictic index? So for generation T2, if we talk about second generation, then this, from this expression I can develop, say, P2 will be equal to 1 minus delta F P1. So P2 divided by P1 is equal to 1 minus delta F. So if you talk about in TH generation, using this analogy for generation, it is Pt t minus 2 1 minus delta F whole square. So in base population, it is Pt divided by P0 and 1 minus delta F raised to power t. So Pt can be written as 1 minus delta F. It is 1 minus delta F raised to power t into P0. So in base population, inbreeding coefficient is 0. So the panmictic index is 1. So if I substitute this value here, so inbreeding coefficient for generation T can be written as Ft 1 minus delta F raised to power T. So now we will talk about in terms of variance of the gene frequency, how this inbreeding coefficients can be written in terms of the change of variance in gene frequency. The variance of gene frequency change in one generation, which we have already developed as, say, it is sigma square delta q is equal to p0 q0 by 2n. And if we express this expression in terms of rate of inbreeding, so expressed in terms of rate of inbreeding, so 1 by 2n can be replaced with delta f. So equation becomes this. The sigma square delta q will be equal to p0 q0 delta f. Now we know that variance of gene frequency at generation T can be written as, if we talk about among lines at generation T, then what is sigma square q? It is, we have already developed P0, Q0, into 1 minus 1 minus 1 by 2n raised to power t. In previous lectures, we developed this equation. So, you will find out the variance of gene frequency at generation T among line can be given by this. And if we express this variance in terms of inbreeding coefficient, so we know that this is P0 Q0, and this term we have recently developed that uh, F can be written as it is 1 minus delta F raised to power T in previous slide. So this variance can be written as P0 Q0 into F. And variance of recessive homozygote frequency due to inbreeding. The formula is, again I am taken from the previous, it is Q0 square plus P0 Q0 F of t. Here F of t is the inbreeding coefficient. And dominant homozygote frequency, on the similar way you can find out P0 square plus P0 Q0 into F of t. Here F of t is the inbreeding coefficient at generation t. So genotypic frequency due to this inbreeding for recessive homozygote, say A2 A2, can be written as Q0 square P0 Q0 into F. On the similar way as we have developed this formula. And genotypic frequency for two allele with inbreeding for say A1 A1, it is P0 square P0 Q0 F, and for A1 A2 it is 2P0 Q0 minus twice P0 Q0 F, and for A2 A2 it is Q0 square plus P0 Q0 F. And so now we will talk about the coefficient of parentage. What is the coefficient of parentage? It is the probability that two genes, one from each individual, are identical by descent. I mean to say, if A is identical to C, or A is identical to D, or you can say B is identical to C, or B is identical to D. And the coefficient of parentage between two individuals, say X and Y, whose genotypes are A and B for X, C and D for Y, can be written as phi xy. It is equal to 1 by 4 probability that A is identical to C plus A is identical to D plus B is identical to C plus B is identical to D. And then the f of A is given by phi xy. And coefficient of parentage of X with itself. Suppose if X is an individual and if it is mated with itself and A is the offspring, then f of A is the coefficient of inbreeding given by phi xx, and this phi xx can be written as 1 by 4 probability of A is identical with A plus A is identical with B, B is identical with A, and B is identical with B. Means X has two genotypes, say A and B. Similarly, this X has two genotypes A and B. So this offspring A has coefficient of parentage is probability that A is identical with A plus probability that A is identical with this B plus probability that B is identical with A plus probability that B is identical with B. So now probability of A is identical with A. It is always 1. Probability of B is identical with B. It is again 1. And A is identical with B. It is Fx. B is identical with A. It is Fx. So it becomes 1 by 4, 2 plus 2f of A, or you can say A. These are A. 2f of A. And if we simplify, I will get it is half 1 plus f of A. And it is equal to half if this x is not inbreed. It means f of A will be 0. So if x is inbreed, then we will find out the coefficient of inbreeding. And if it is not an inbreed, then its coefficient will be equal to 0. So it will becomes half 1 plus 0. So it is half if x is not inbreed, or you can say inbreeding coefficient is 0. Now, coefficient of parentage of individual A with offspring B and C. How you will find out the coefficient of parentage? So you will see the coefficient of parentage of individual A with offspring B and C. So with similar notation, you can find out this is the coefficient of parentage A with B and C. So suppose A have two genes, say Y and Z. Individual B have two genes, say U and V. And suppose individual C have genes, say W and X. So first of all, we will generate the genotypic array of the progeny of B and C. So genotypic array would be given by 1 by 4 UW, VX, VW plus VX. Because we have A individual having Y and Z. These are the two genes. And the progeny, the genotypic array of progeny of B and C. B has genes, say, U and V, and C has genes, say, W and X. Now, if they are mated together, then they will produce, say, A. And what is the genotypic array of these two? So, this can mate with this. So, U and W. So, UW plus UX plus VW plus VX. So, it is 1 by 4 UW, UX plus VW and plus Vx. Now the coefficient of parentage phi ABC, it is given by 1 by 4 the genotypic array of this. Say Y is identical with U, Y is identical with W, Z is identical with U, and Z is identical with W, plus 1 by 4 Y is identical with U, Z is with identical U, Y is identical with X, means all possible combination we have taken into account. So if we simplify this expression, you will get 4 into 4, 1 by 16, P Y is equal identical with U here, and we will get another. So it is twice, every identical is twice the total one. So y is equal to u, you will see again y is equal to one more u, this one. So y is equal to u and y is equal to u. So it is twice y is equal to u. Similarly, we will get twice y is equal to w. Similarly, we will get twice y is z is equal identical with u. Two times probability that z is identical with w. And similarly, you can find out all these things. If we further simplify it, you will get 1 by 8. I just take 2 common from all these expressions. And this expression can be written as py identical with u plus py identical with w. And u and w, you will see u and w. So it becomes phi of AB. ZU and ZW plus 4 times A of C. So if you simplify it, you will get this expression. And if I take 4 common from this expression, I will get it is half phi of AB plus phi of AC. I mean to say, if you want to find out phi of A, B, C, where B and C are the parent and A is the offspring, so this can be given by half phi of AB plus phi of AC. This A is distributed to B and C. Now, we will take certain example which will make you more clear how to compute the inbreeding coefficients. So, there are two methods of computation of inbreeding coefficient. First one is, you can say, pedigree method, and second one is the co-ancestor method. And in pedigree method, we trace the pedigree back to the common ancestor of the parents and compute the probability at each level of segregation. So if we consider an example, suppose this is my pedigree. In this pedigree, we are interested in individual X, whose parents are P and Q. And we want to calculate the probability that X receive identical gene from a common ancestor, say A. So this pedigree can also be written as, this is a common ancestor having two offspring, say B and C, and this is D, C is again Q, and we have, say, P and Q from this, and then you will get X. So how you will find out the coefficient of inbreeding? So there are certain steps. Step 1 is, we will consider the probability that sorry, Q inherits an identical gene from this ancestor A. And what is the probability that B receives identical gene from the gene A? So it has two offspring. So probability that B will receive identical gene from A is half. So the probability that B receive an identical gene from A is half, and probability that the C receive it it also receive identical gene from A, and its probability is again half. Hence, the probability that B and C receives different genes from A is also half each. So the probability that B and C receives different genes from A is half each. Now step 2. Now trace the gene further down the pedigree. If we further move like this, so D will receive identical gene through B is again half. Probability that D receives an identical gene through B is half. And probability that this P receive identical gene both D and B is again half. And probability that X receive an identical gene through P is again half. Thus, the total probability that X receives identical gene from A through the path PDB. So, probability that this individual X receive identical gene from the parent common ancestor A through the path PDB, it is given by 1 by 2 plus 1 by 2 into 1 plus FA 1 by 2 raised to power 3. Similarly, the probability that this X receives an identical gene from A through the path Q and C is given by 1 by 2 into 1 plus FA 1 by 2 square. So we have only one dash. So the total probability that X receive identical gene from this ancestor A is the sum of all these probability, and this sum can be written as 1 by 2 into 1 plus FA 1 by 2 raised to power n1 plus n2. Now this n1 and n2, what are these? N1 is the number of generation from one parent back to the common ancestor A, and N2 is the number of generation from the other parent back to the ancestor. So X has parent P. So how many generations this parent is apart from A? We have 1, 2. So it is 2. So sorry, 1, 2 and 3 generation. Similarly, Q is apart from 1 and 2 generation. So if I simplify this formula, so we can find out the coefficient of inbreeding of an individual X can be written as 1 plus f of A 1 by 2 n1 plus n2 plus 1, this one. So you can write N1 is the number of generation from one parent back to the common ancestor A, and N2 is the number of generation from other parent back to the common ancestor A. So using this formula, this is known as pedigree method. We will first find out the common parent and we will trace the pedigree and count the number of generation from each path, and then we, using this formula, we compute the probability of that path. Then all the probability will summed up and you will get the probability, or you will get the coefficient of inbreeding of that individual. Now we will do some more example quickly. So first one is From the given pedigree, find the inbreeding coefficient of Z. Now, where is Z? This is my Z. Now, this is the common ancestor. Now, you will see inbreeding. Now, this ancestor we have no pedigree of this ancestor further. So, the coefficient of inbreeding f of x is 0. Now we will trace the path back to the common ancestor. First of all, we have common pedigree. Common parent is x only. And you can reach this x through many paths. One is z, y, d, x. Other is s, a, x. You can also reach through s, b, x. You can also reach through z, y, c, x, and so on and so forth. So I am just writing down. So first of all, we will trace out the common pedigree. Common pedigree is my x, and I am following the path, say S A X D Y. So S A X D Y back to this one, and in this path you just count down n1, n2, or you directly find out their sum. So I use z to x. We have 1, 2. So n1 is 2. Similarly, 1 and 2. n2 is 2. I use this formula 1 plus fa into 1 by 2 raised to power n1 plus n2 plus 1. So just I substitute, I will get this. There is another path, that is S A X C Y. Again, n1 is 2, n2 is 2. I find the probability is 1 by 32. We have another path, SBXD by SBXDY. Again 2, 2. We have one more path, that is SBXCY, and n1 and n2. I have both 2. So I will compute the probability of each path, and then I just summed up. So it is 1 by 32 plus 1 by 32 plus 1 by 32 plus 1 by 32. It is 4 by 32, and ultimately we will get 1 by 8. So there are one more example. This is my pedigree and I am interested in finding out f of k. So what are the common parents? You will see A is my common parents, B is my common parents, and I have D. D is also my common parent. D is also common parent. Then how will you find out the probability? So you will trace the path. If I take common parent A, then how you can reach H, G, C, or you try trace from like this D, A, C, G, and H. One path. So D, A, C, E, F, and H. There is another path. You will have D, B, C. So these are the paths through which you can reach to the common parents. And these are my N1 and N2 for each path. I just substitute these value and take the sum of all these probability. I will get this. One more example you can take. From the given pedigree, find the inbreeding coefficient of E. How you will find out? So again, we have two common ancestor A and B. So one common ancestor is A, and this is CAD is my one path. Another common ancestor is B. CBD is my another path. CAD, this is one generation, this is one generation. So N1 is 1, N2 is 1. DBC, again I have one generation and one generation. So I just find out the probability of common pedigree for A as well as for B, and just sum up you will get the coefficient of inbreeding E. If you take one more example, find the inbreeding coefficient of Fs from the given pedigree. Now, from this, you will see I have a common parent O. I have also a common parent P. This O has also a common parent L. So, since we have no information about the parent of L and P, so their inbreeding coefficient of Fl is equal to f of P is equal to 0. But O is also a common parent. So, and it is also, and O has two parents M and N, which has a common parent, say L. So, first we will find out the inbreeding coefficient of O, then using that inbreeding coefficient in order to find out the coefficient of inbreeding of, say, S. How? So, first of all, we will find out the f of O. Now, O has two parents, M and N, which has a common parent, say L. So, if I have common parent L, then what is my path? M, L, N. And there is one generation here, one generation here. So 1, 1, and you will get the probability 1 by 8. Now this is f of O, 1 by 8. Now f of A or f of L is 0 because we have no information about the parent L. But now we will find out the probability, or we will find out the coefficient of inbreeding of S, which has common ancestor O and P. P has, we have no information about the parents of P, so f of P will be 0, but f of O can be taken as 1 by 8. So I just want to mention only this thing. Here you should not take f of O as 0 because we have the information of parents of O and we have computed the coefficient of inbreeding FO as 1 by 8. Now using this path, only this path, you can find out the pedigrees. We have a common pedigree O, we have a common pedigree P. If we considering common pedigree O, then my path is ROQ. Having one generation here, N1 is 1, N2 is 1. But f of O will be 1 by 8. So I will substitute 1 by 8 instead of f of A is 1 by 8. Generally we put it as 0. So it is 1 by 8. You simplify it, you will find out. And in second pedigree, common parent, this is RPQ. This is R, P and Q. So RPQ, there is one generation, but we have no information of parents of, say, P. So its f of P will be 0. So I use 1 plus 0 into 1 by 2 raised to power 1 plus 1 plus 1. So it is 1 by 8. Now add these two probability in order to get the coefficient of inbreeding of S. Then one more example. Similar example is there. Now, this is my common parents. These are my two common parents, M and N. So, I want to find out f of Q. So, Q has only two parents, P and M. So, I have only one path, common parent. L is not my common parent because Q's parents are M and P. P's parents are L and O. Right? So This is QMOP. So you can say POM is my path. So there are one generation, two generation for N2, and there is no generation of N1. So it is 0. You will find out the coefficient of inbreeding as 1 by 8. One more example. This is my pedigree, and we want to find out f of f, the inbreeding coefficient of this individual. F has two parents, D and E. D has two parents, C and B. C has two parents, A and E. Right? We have no information of the parents of A and B as well as E. So their coefficient of inbreeding will be 0. Now we want to find out F. So we will trace the pedigree. So F, D, C, B, E. One path. Another path is D, B, E. Another path. And third path is D, C, and E. There is another path. You just put the N1 and N2 and just sum up all the probability. So in this way, you can find out the coefficient of inbreeding from pedigree method. We will discuss these examples. We will also solve these examples through the method of coefficient of parentage. So thank you very much.